you everybody for joining my talk. Today is the last talk of the day, so I wasn't actually expecting so many of you, so thank you very much. I thought maybe you were tired and wanting to go to party, but thank you for coming. And so as such, the topic, I call it Enter the Brave New World of GenAI with Vector Search. So as we all know, Brave New World is a very famous science fiction of the time, right, by Aldous Huxley. I think that's the proper way of pronouncing in British way, Aldous, not Elders in American English. So anyway, so I feel that it is a very appropriate title because it's, as we all know, the Brave New World too is like experimenting or kind of like exploring into themes of this dystopia of like new things that are going to take over the world, take over even how we think about things. But of course, too, like right now with ChatGPT, I think there are people worrying about it, but I really don't think it would be at that point yet. I think there were a lot of hype, as we all know, when ChatGPT came out. But certainly, too, I do see this as not something like Bitcoin that just came and go, it seems to be. And I think there still is going to be here to stay. There's going to be very interesting things that can be developed from this movement. Anyway, so thank you very much for coming to my talk. And let me just real quickly just show you the agenda of what I'm going to be talking about. But also, first of all, just to let you know, this is more introductory, a beginner level, just assuming that you are all very experienced developers, and but you may be new to generative AI, to ChatGPT, so that's intended for that. So it's not going to be too in-depth into a lot of things, but I try to touch upon a lot of different topic areas that are kind of representing this Gen AI evolution. So this agenda, I'll just do some introduction, giving you a brief background of AI, and then understanding the players in this Gen AI era, and then talk about the terms, the GPTs, the LLMs, the NLP, RAG, and then also vector database, all of these things. And hopefully we'll have also a little time just to show a quick demo and then discuss some of the benefits and challenges of this ChatGPT thing. And that's the plan for today. But may I actually first ask you, how many of you are already working with like generative AI applications maybe? Okay, so quite a few, actually. Yeah, so thank you. Are you mostly Java developers here, like that are working with Gen AI? Oh, not as many. I guess most of you, I'm guessing, are using Python, maybe? Yeah, Python or JavaScript, maybe? Yeah. Anyway, I'm just kind of most curious, too, to see how much of Java these days, like being used and utilized for Gen AI. So just kind of an interesting thing. So yeah, that's my plan. Hopefully it will be helpful for you. So first of all, very quickly too, who is Mary? Who am I? I'm a very passionate developer advocate. That's how I describe myself. I was here last year too, when JCon came back to in person. So I was here. So very happy to be back. But during COVID too, I spoke at the virtual ones too. So, and really kind of thankful to Richard and the organizing team for having me here. I'm also on the program committee as well, also volunteering too, if you had seen me at the registration desk this morning. So, and then other things about me, I'm also a Java champion. I'm also a very active organizer of the Java users group in Chicago. So I'm the president of CJUG. And then other things is that I actually have a background in development, so I was software engineer first when I first started my career. It's like over 20 years in more Java, open source, cloud, all of these things that are so common to all these things. So I understand too, especially if you're developers working, having had to deploy to production, all of these things. So that's me, but then about 6 years ago, I started doing developer advocacy work. And if some of you are new to advocacy, is essentially we go out and do talks and outreach and working with developers and making developers success. That's our goal. And currently, I'm actually in between jobs. I actually will be starting as a Gen AI practice lead for a consulting firm. So I'm going to try something slightly different. There's still going to be evangelization, but also I will be doing some consulting work too. So just wanting to transition back a bit, doing client work. So that's me. And then that's how you can get a hold of me. But I'm going to share with you again how you can get a hold of me towards the end of this presentation. So myself, though, I have a math and computer science background. So when I got into working with Gen AI, I actually was happy because happy in a sense was that in the beginning, of course, I was at DataStax, and then they said, okay, we're going to all be doing GenAI. And then I have to come up with new topics very quickly. And like I told my friend here, Hedy, and he was asking me, did they give you idea how to do it? I said, no, it's just have to go do it. And so I actually looked back some of my linear algebra math book, right? So that's for vector database search. So it's very applicable. A lot of math that's involved too, if you want to get into that level. So that's my background, and then I was also a developer, as I mentioned to you earlier. So okay, without further ado, I'm going to start. So a brief background of AI. So just really quickly too, if you kind of think of the artificial intelligence age that we are in, just look back about, little less than 100 years ago. That's when the current stream of AI wave is kind of starting with the fact that there was actually coming out of literature, science fiction, golden age of science fiction in 1938 to 46. And then eventually, too, all these other things. This is just a highlight of what happened during that time. But the thing is, too, with Alan Turing, father of modern computing, came out with this book, right, that talks about can machines think. I think that's the ultimate thing. Basically, too, it's kind of making us humans less having had to even worry about what to do. We are relying on the computer, the robot, to think about what needs to be done. So I think that would be the next phase. But to me, I think right now the ChatGPT is not quite ready for that. And the main reason I feel is that we still need to prompt it. So to me, I'm thinking if you need to prompt it, then it's not truly artificial intelligence, because you have to know what to ask in order to get what you want. But the idea should be, you don't quite know, you just ask the robot to kind of suggest to you what needs to be done. But I don't think it's truly capable at that stage, but maybe at some point it will. Okay, so that's that, but it's just very quick history, as you can see in here. All of these things that are happening, but I do want to highlight too, because I work for IBM too as a developer advocate, so I like to point out basically Deep Blue in 1997. That was also a very dedicated AI kind of example of Deep Blue playing chess and then beat Garry Kasparov, the chess kind of champion of that time. So that's kind of like the past, century in which we know that 20th century was kind of starting to have all of these, excitement research being done. And then now we are in, the 21st, or actually now it's like 21st century. So we have even more stuff, which is the ChatGPT that was born. Okay, so let's kind of take a look again. So this AI revolution is really about automation. We're talking about automation here. Oops, let me go back. So if we kind of take a look too, just kind of high level understanding this, category of computing. Basically, artificial intelligence is kind of really more of a concept, higher level concept, and kind of thinking of it like an onion, right? This thing. Using set theory, AI encompasses everything, and it mimics the intelligence and behavior of human beings or any other living entity. But then we get into machine learning, and machine learning is exciting. It's really the techniques of us not even have to teach the computer to kind of explicitly think, right? It's basically you're giving it data and have the machine figure things out. But then just machine learning technique isn't important, or isn't sufficient, because then you get into the next level, deeper into it. It's really the deep learning, which involves getting into neural networking that's mimicking how our neurons work, right? Then that's kind of deep learning, and that's where currently all of the LLMs, all of these deep learning thing that's kind of mimicking how our brain thinks and thinking in different layers, so to speak, right? And that's where things are happening. The ChatGPT, all of the imaging that are happening, all of these are in that layer. So with that understanding, let's take a look then into fascinating, this GenAI era that kind of captures so much of our attention. As we all know, ChatGPT came out 2022, so roughly over a year and a half ago in November. It came out, and it's a very disruptive field of AI. It basically has turned the whole, it captivated all of our attention. And the way it is that it has the capability of changing the way how we create content as well as consume the contents too. And basically, it generates new contents based on prompts. As I mentioned too, we do need to rely on prompts in order for it to generate the content that we need. So it uses a combination, right, of machine learning as well as deep learning kind of techniques to produce contents. Now, the thing is, too, is that you may be thinking, well, it's not quite completely all new, which is true, because we had actually predictive AI before that, which is predictive is a bit more, has a time component or time validity component to it. And if you think of like business forecast, weather forecast, you can be giving it data and it goes figure things out. But the difference is that, right, with generative AI is that we're talking more about creative content that isn't so much as a time boundary to it. Like we're now talking about creating, writing an essay, producing a piece of music, writing code. All of these are less bounded by time. And not only that, too, with Gen AI is that it's taking prompts in the form of human languages. You can speak to it like you speak to another person, which is very different. Because it used to be traditional computing, you do need to tell it what to do. You need to pass in parameters, all of these things that needs to follow very strict rules. But now with Gen AI is that you talk to it like another person. So that's kind of like the new thing. So a bit of history too. Let's kind of go back, with this evolution of kind of development of this space. So in roughly like 20 years ago, Yoshua Bengio and his team developed the first like feed-forward neural network language model. And then not long after that, Apple then brings AI and natural language processing assistant to iPhones through Siri, as most of you, if you're already using it, that was quite revolutionary. And in 2013, so just about 10 years ago before, right, in 2013, that was Word2Vec that came out from Google. And that's actually important because that actually forms the basis of today's like vector database searches based on Word2Vec. You're converting words into vector. So that's what I'll be talking about in a little bit. So that technique too is important as such, for natural language processing. And then 2017, that's when also then the transformer, that paper came out, is a simple network architecture from Google. And if you have been following all of these AI research, when you hear about this phrase, attention is all you need, and that's when that paper came out too. And that was also transformative. It kind of emphasized on this transformer architecture. Okay, so that's a bit of that history of GPT. But let's kind of take a look too at this Gen AI era of all of the players that are involved. Players in terms of what are things that are involved, right? A little bit more solid. So first, let's take a look then in like the models, right? The models are kind of what kind of form this basis of able to kind of help us to reason things out. So as such, right, OpenAI, as we all know, is kind of the most famous of all that has the GPT model that came out 3.5, right, in November of 2022 that came out. And then these models, again, these are foundational type of models that requires a long time to pre-train and be produced, right? And then there's also like other models such as Codex, that's actually more for coding. That's what GitHub Copilot is based on, Codex. And then there's also then Llama 2 in here, Llama from Facebook or Meta. And then also want to point out too, actually I was kind of putting a question mark of BERT, because BERT is interesting. It came from Google. It's an earlier form of LLMs. And that's what, when I was doing research, my understanding is that. However, somebody from DevOps UK, I was there doing presentation. Afterwards, he told me, he said, BERT is not really LLM, but maybe somebody can correct me whether it should or should not be called an LLM. It's kind of a little confusing to me, but to me, it's still some kind of transformer, because as such, it stands for bidirectional encoding representation transformer, or for transformation. So it's a form of transformer. And essentially, that's what LLMs are. You are taking data and you go through many stages of transforming. So they are transformation, kind of with that purpose. So anyway, BERT is a very early form, if we call it a model. Okay, and then there are also other models too here that I kind of put out. For example, stable diffusion. That's also kind of revolutionary because it's essentially the first text-to-image type of models that came out. So after which is Dolly and Midjourney. These are more image type of models that for generation that came out too because of stable diffusion. And there's also Whisper, that's more audio, like that. So, and what else did I forget? Yeah, so these are, again, just a small sample of the more popular models. And then the next thing is that basically, too, there are only models, but it's not useful unless you have apps that are making use of it. So over here is just example of all of the apps. So there's ChatGPT essentially you can consider more like an app that makes use of GPT that model to do your thing. And then GitHub Copilot is depending on codecs that model. And then here too, wanting to point out there's Bard and Gemini from Google, and actually Gemini came out quite recently, right, like a month or two ago, and it's kind of quite interesting and very innovative because it's supporting multimodal, and I'll talk about the modality in a little bit too. And then there are also other ones, as you can see in here. There's Bing from Microsoft, and then SEO AI, Salesforce, all of these other vendors also comes out with their own generative AI apps that folks can use, basically. Okay, so now I'll talk a bit too about players, about the modality. So this is kind of an interesting aspect of this generative AI kind of revolution, so to speak. As we all know, if it all first come out too, is we're talking about text-to-text type of generation. You prompt it using text, it will come back to you with answers that are text, right, coming to you. But what is making it even more kind of useful is being able to do text to image, which Stable Diffusion is already doing that, and so that's that. But then there are also essentially these are the 6 different kind of forms of modality the modes that you can think of in the type of format of data that it can be generating or kind of feeding into a model too. So in other words, a text or image or code, audio or video or 3-dimensional kind of data. So these two is basically, if you can do multimodal, is actually more useful. And as such, OpenAI also came out with Sora, that model in which you can do like video, text to video or video to text, all of these things. So basically, you can have the LLMs look at a video and analyze it and produce you results of text. So that's kind of even more useful, right? You can have video and produce kind of converted to image, for example. This kind of modality kind of interchange is actually kind of a very, very popular kind of, how can I say, like it's very, like a research that's being kind of done quite a lot to these days, because it's kind of, adding value to what you're trying to look for from your information, so. Okay, so now then let's also take a look too in terms of the people player in this space, right? So we're talking about where we are all developers. I'm assuming most of you are developers here, so we're more developers, but there are also then new type of role in terms of there are data engineer and AI engineer too. But to me, right, there's this fear of what if ChatGPT comes out and then take away our jobs. But honestly speaking, after working on it for about 6 months, I feel like no, it won't be, because there's still so much work to be done. And not only that, I mean, the fact that we're developers, actually, it's actually going to be very useful to help to create programs, to implement solutions, and for ChatGPT, GenAI type of apps too. And not only that, there's also, for example, DevOps folks can expect to be doing ML ops, for machine learning type of kind of tasks. We know there's machine doing pre-training, and you need to constantly be feeding data in and updating the model. That's kind of ideal, but I think in reality, your large language model is going to take a long time to produce, so it's not possible. But the thing is, though, you can actually produce your own private model too. So those you have to think of being able to do continuous, like machine learning kind of pre-training kind of models, as well as then there are apps that are going to be doing inferencing. You're actually then going to apply, your model knowledge to produce answers that you need for your applications. So all of these, I think, they will create new jobs rather than taking our jobs away. Not only that, I think there are also problems of hallucinations, which I'll talk about in a little bit too. Which means that you can't be truly trusting LLMs. It can come out with wrong answers. All of these things, we need actually people to verify that your ChatGPT application is doing the right thing. So I think there will be still tons of jobs. And of course, all of these data engineering are more dealing with how-tos, how to do something, but the what, is like, what is the data supposed to be doing? All of these are relying on data scientists, that they know what should be done, all of these things, and computer vision engineer, the subject matter expert too. So these are kind of like players that are in this new era space. Okay, so now I'll just step through all of these new terminologies. Basically, there's GPT. It stands for Generative Pre-trained Transformer. So what it is that it essentially, too, it takes simple prompts, right? So again, the prompts nowadays, we don't need to actually writing them down following strict rules. You can just talk to it like you're talking naturally to another human person's. And so these becomes the input to your to what you need to do. It's like command prompt, what it used to be. Now it's kind of just natural language prompts. And what it does is that it will do all of these pattern matching or similarity searches behind the scenes, and then it answers the questions for your prompt and produce content such as writing a new essay, writing a blog post, designing a dress, right, and producing code for you when you need it. All these are GPT functions. So GPT-2 real quickly too, it started showing up around like 2018. And it was actually, first of all, it was OpenAI. There was Alec Radford had a paper on GPT. That was the early form. It's only 2018, like 6 years ago. And he produced that. But very soon, in 2019, then OpenAI releases the complete version of GPT-2, which actually encompasses a bit more of the documents to include that. And then very soon, 2020, well, then a couple years, all of these, time goes by, and then a lot more research being done. Then essentially, too, I mentioned about stable diffusion, text-to-image model came out in 2022, and then very soon, 2022 end of year was GPT 3.5 that came out. And as we all know, within like 5 days, there were like a million users downloaded that, and everybody has been kind of excited about it. I feel that right now, actually, the hype has died down a little bit because everybody is still trying to figure out what it can do. I think certainly it can wow us, but to do real production stuff might take some time. It's not quite ready. Okay, so now today too, 2023-24, all of these ChatGPT still continues. I think there are a lot more talks about, starting to have talks about regulation, for example. Still kind of not quite there yet, but I think there's still research being done in there. Okay, so now let's kind of move on to the next thing, which is NLP, is natural language processing. So NLP is basically an interdisciplinary subfield of linguistics of computer science. So the concern is to try to process the natural language data sets, right? These are called in machine learning terms like corpora of speech or text kind of data, huge, right? So then it uses rule-based and probabilistic machine learning approaches to kind of process these huge, languages that comes in. And it enables the computer to learn, from contents and including contextual nuances of the languages itself. And the idea is that you want it to be able to draw insights too from the documents, not just, what it used to be is more strict about you do something and then you search for the answers and that's it. But now too, it can come back with like a context, something that's close enough, kind of in that sense, right? When you need to search for some answers. And that's why too, it explains sometimes when you use some LLMs, you query it at different times, it can come back not exactly giving you the same results. It's because that kind of techniques that's being employed. Okay, so now the next thing then is basically LLMs and its developers, and that's what we interact with directly when we do coding, all of these things. And LLMs, large language models, are a type of machine learning models. And it's foundational type of model. And then usually too, for the general generic models, for example, ChatGPT or GPT, right? And it's basically, it requires a lot of resources to kind of produce, the results, and a lot of GPUs to kind of churn out, process all of these data. And then inside is doing all the fine-tuning of all of this data. And it takes like weeks, to produce that model. So it's not very easy. And it performs NLP kind of tasks. Essentially, too, inside it does all of these generation of text, classifies all of your data, putting on labels, all of these things, if you're familiar with machine learning. And that's where all of these things come from. And the idea is that working with LLMs is that we most likely are using it to do like chat completion type of application kind of usages. So it's basically you want it to answer questions and the prompts just like a human being. you want it to analyze sentiments too, not just answer the questions as is, but you want to analyze more than beyond just what it says. You want to suggest more results from it too. So that's kind of a bit of a kind of magic thing. So now let's take a look back into that original set theory diagram here. If you kind of look at it, what is an LLM and how does it fit in with that original diagram? As you can see, this AI is still that umbrella, then there's machine learning, and then this is where LLM sits, is inside the deep learning, that kind of, like, for example, the ANN, CNN, all of these convolutionary neural networks, and actually the RNN is recurrent neural networks. For example, they are just different terminologies describing all of these machine learning kind of techniques that's being used. And then generative AI too is part of the deep learning, but underneath like generative AI, you have the transformers. All of these, and GAN stands for Generational Adversarial Network. And then the other VAE is variational autoencoder, something like that. Yeah. So anyway, I haven't gone into all the details. That you do, if you're interested, you can get into it and can go pretty deep. And essentially, too, that's image generation with the GAN and the VAE, and then LLMs is dealing with all of the transformers in here. As you can see, that's how like data science is being applied, all of the data being applied to doing all of the processing in here, and makes use of NLP to do all the work behind the scenes. So that's kind of like in a nutshell. Okay, so now you may be asking, well, how can I work with LLMs, right? So as such, yeah, these are kind of quite popular libraries out there. They're not just these, but as we all know, or maybe some of you are already working with, like LangChain. It came out in 2023, 22, so quite recent, but it's already very highly popular. And it's primarily Python. It also has JavaScript and TypeScript to it. Then there's also Llama Index too. And these are kind of quite popular ones. And of course, Semantic Kernel from Microsoft too. It's also open source. Also has a Java SDK. And then from Google, there's Palm that works with their Vertex AI. And then there's also, interestingly, if you are interested in getting all the models, you can go to Hugging Face. And think of Hugging Face like a GitHub repository, but Hugging Face is for AI models, these GenAI models too. So it's all free, you can register. But make sure too, your machine has a lot of storage when you download them, because I actually try it and it's taking a long time. Yeah, but anyway, I'll tell you something else about Hugging Face. It's kind of funny that I will tell you after. Okay, and then so now this is more of a Java focus the conference, so we have to share something with Java. So these are LangChain 4j. I think LangChain 4j is not the same as LangChain, just so you know. It's a separate group of folks, and in fact, I think at DevVox too, there's Liz been kind of making talks too, and it's really good on LangChain. She works on it, she's a committer. And I think that one is like closest to LangChain, but it works pretty good, and I'll show you kind of quick example shortly. And then there's also Semantic Kernel, as I mentioned earlier, that has Java SDK, and I do see Soham in the audience from Microsoft. He works with that too, Semantic Kernel. And then also do want to point out too, that's interesting with JLlama here. It's actually, I work for DataStax, and Jake actually is the architect at DataStax, and he worked on a porting of Llama. It's based on Llama 2 at the time when I left 2 months ago. He was still working on it. It's a Java port of the Llama. And that's the thing I wanted to tell you, because I was trying his thing out. Actually, I just didn't have time to set it up, but it's not actually very difficult if you go there. And I was trying it out, and so I downloaded a model and was using a small one, the GPT-2. It's kind of mid-size, if you look for that. And then I downloaded it, was playing with it using JLlama, and then I was listening at the time to some old songs, and it's something like in the Beatles time. I was saying that who is this singer, or some singer came out, and I asked, who is that? And instead, the GPT-2, instead of telling me I don't know, it started swearing at me. It's like, why do you ask me? I don't know, it's something. It's kind of funny. So I just want to share with you, some of these older models can have very interesting results if it doesn't know. Yeah, so it was like swearing at me. I was like, oh my gosh. Anyway, so that was something I thought I'd share. Okay, and then, so now just a little more about information about Java-based frameworks is that there's also a JVector. It's actually by Jonathan Ellis. he is the one of the technical co-founder at DataStax, and he did this vector implementation that's based on Project Panama. And it's really fast, to help with vector math, vector API searches too. So I just thought I'd point to your attention, but currently it only works with Apache Cassandra and also the managed cloud at DataStax. So, but it's actually quite efficient too. If you need more information, I'm still friends with them, so I can ask them too. Okay, so then there's also another Java-based framework. It's called Llama 2, and that's actually based on Llama C, and that one is a direct port from Llama C. So just something to share with you here. Okay, so real quickly then, let's take a really quick look. I won't have time to write it. It's Hello World in LangChain 4j. And as such too, in order to do a very plain, this is really the simplest thing that you can think of doing a quick, kind of a ChatGPT app in LangChain 4j. And what you would need is just an OpenAI key. So once you set that up, and as you know, you can get a key. And the thing is, if you use ChatGPT 3.5 model, that's much cheaper than using 4.0, but if you haven't already done it. So you can quickly get that and then plug that into your OpenAI API key. And essentially, too, you just do a model and associate your API key and should be able to then do a generate well, in this particular case, it's just generating the string that comes out of it. It's not really like doing a lot of fancy stuff. But so this is just a really quick example of a LangChain 4j, very basic example. Okay. So next thing I want to really quickly also talk about is this retrieval augmented generation, which you may have heard of it, RAG. And this is essentially a design, more like a design pattern than it is with any kind of implementation. Basically, it's a hybrid framework that integrates like two components of this RAG model. So why is it needed? It's because if you think of it, LLMs, large language models, even though they are humongous, seems like a kind of all-powerful, but the thing is, it only very static data. For example, the GPT 3.5 that came out in 2022, it's got data only up to 2021. So then what do you do with it, right? There's data. I mean, the world keeps going. You need more data. So then that's when, the industry comes out with this whole approach. They call it RAG, retrieval augmented generation. I mean, as such, you can kind of imagine it's basically you have to like augment what your LLM is missing. So essentially, too, this model is that this framework, it involves two models, two components, which is retrieval model and also the generative model side. And so the idea is that it's to produce text that's not only contextually accurate, but also like rich, information rich too. So that's what being done by the generative model side. So just really quickly to point out role of the retrieval model. So kind of think of retrieval side is like a special librarian in here. It's just pulling in relevant information from a database or from some external data. It actually can be a stream too, if you kind of think of it. I actually have another talk that actually I was showcasing an open source library called LangStream. And you can basically also plug in a stream, a Kafka stream, or however you want to, you can do that as well. So external docs, and that kind of serves as your retrieval model, and it kind of supplements what your LLM is missing too. And then with this, then you can then feed that the information, what you retrieve, and feed it to the generative model side. And then the generative side will be like a writer that basically produce the contents that you may be looking for. Okay, so now then take a look at the role of this generative model. So think of it like a creative writer. It synthesizes the retrieved information into kind of very coherent and contextually rich kind of text too. And it's basically too, it's also built upon LLMs, and basically it's kind of guarantee your words should be grammatically correct and semantically like meaningful, all of these things too. And it's also basically kind of produce things beyond, it's supposed to be beyond what we can normally do. And it does its job really, really quickly too. So think of it kind of generative model as the side that kind of produce to you the final piece of the puzzle when you need to try to do something, generate an essay, kind of producing some beautiful painting, for example, things like that too. So that's the generative side. So that's essentially sums up. And let me then really quickly then talk about also to vector database and similarity searches. So in this ChatGPT time, right? We're dealing with data that's basically multidimensional. So what does it mean by multidimensional? So think of it like your data is no longer just scalar type of data, like kind of single dimension. We're talking about multidimensional data that it carries more information, the dimensions, all of these, what is called in the math term is the magnitude of this data too. So then, in order to be able to, let's say, right, you're working with LLMs, and LLMs are just static piece of kind of big blob of data. It doesn't do anything. It doesn't preserve the state. If you try to query, in between queries, you need to save the data, for example. Then what do? You can do it in memory, but you can only do so much. So maybe you want to consider using a vector database to help you to store it, as well as to allow you to do queries against data. So that's the reason why we want to consider using a vector database. So the thing is, though, because we're now dealing with multidimensional data, so the data has to be kind of special. But it sounds like intimidating. Okay, change it into, you have to convert your data into embeddings. But embeddings essentially are just numerical representation of the data that you wanted to store into your vector database. But these embeddings too, how does it convert it? It also, you will have to rely on the embedding model. So OpenAI also, usually you'll be using OpenAI or another organization, Cohere, for example, or Anthropic. I think they also have their own models too. But make sure that if you use the model to store them, you want to use the same model to basically do retrieval as well too. So, and essentially too, these numerical representations, if you look inside a database, they are just a whole bunch of numbers, but they are actually just arrays of what you call floating point numbers too. So in other words, if you want to convert like a string into numerical representation, you use that specific model, it will translate it, and if you select that column, it will show you a bunch of numbers, and they are just array, depending on how many dimensions you want it to, and it will store them accordingly into your database like that. So this is also called it's also a form of feature engineering. And then in machine learning terms, feature engineering is more like about your data being like features. They are being like kind of more like you're fine-tuning it and kind of producing closer to what you want. Kind of think of it like that. And also too, with vector database, it's making use of these techniques called approximate nearest neighbor to do all of the searches. So what is behind the scenes is basically all of the linear algebra math behind the scenes. So that's vector database. So let me kind of explain a little more too. So essentially too, if you kind of look into embeddings, right, you can kind of think of your data as no longer like blob on a single dimension right there. We're talking about two-dimensional, and it can be up to many dimensions as well for vector data, kind of data. It can be three-dimensional, four-dimensional, however you want. But in this particular example, I'm using a two-dimensional normalized vector. So over here too, this embedding model will transform your data, and then if you represent it in space, in a two-dimensional space, it will be, for example, vector 1 is there, and vector 2, it has that direction where it's located in this graph, in this case. So it can be, many dimensions as well, and as such, right, OpenAI embeddings are 1,536 dimensions currently. And then if you kind of do searches, let's say, you're kind of, let's say the V3 is the search query vector, the one that you're looking for something. And then you find V1 and V2, so naturally then V2 will be the one that will be returned to you because it's closer to V3 in this space. So that's kind of the idea of this vector database and the similarity searches. So just to give you a bit more kind of realistic kind of look at it, just now it's just using math, V1, V2. But over here, let's say I have cat and dog. That's how it's being represented. And I'm looking for a house. But actually, the dog is closer. It's perhaps like dogs is more loyal, right? Cats usually run around. So then you maybe will be getting an answer. In this case, will be a house that's closer. Now, in reality, too, when you try to do query too is that you can also do select, usually, right, doing SQL database, you could do a select, all these columns, and then you can also say, I want, what is the percentage of, of the closest proximity I want the answers to be. And let's say I want 5%, then it will only return to you the closest, like 5% to what you're looking for example, like that. So yeah, and today is a little bit of a quick demo, so I don't have the actual demo to show it to you, but maybe if you follow me on my live stream, at some point I'll start doing it, I can show you that. Okay, so then now, let me kind of getting a little more, but I won't get into all the details, is that, that's what it's using, right? Using this kind of vector search kind of approach is essentially to, what I was showing you, it seems like it's only one single plane. But in reality, too, your data can be very complex, many dimensions. So it involves actually multiple layers to do the math and arrive at your similarity search results, too. So and this is just kind of to show you kind of graphically what it looks like. So essentially, too, to summarize, right, all of these built-in algorithms for fast retrieval is really called the nearest neighbor embeddings. So it can be doing Euclidean, if you're again familiar with math stuff. They're Euclidean or cosine similarities, or doing dot product or dot matrix type of searches. But these terms all comes out of linear algebra if you are kind of interested into that. So yeah, this is kind of a new type of data that's supported in kind of multiple established databases, but I want to cite some example. For example, OpenAI has this, actually, is it OpenAI? It's a Pinecone. This is a popular, but it's not an open source database. But there's also like PG Vector as an extension of Postgres, for example. Chroma and Milfus, Weaviate, these are all open source type of vector-enabled database too. So if you want to look into those. Okay, so now I think I've only about 5 minutes or so, but just share with you, just now I mentioned about, these are just some of the examples of the more popular vector database. These are open source one, and I'm just assuming, folks, if you want to try out, I actually have done some PG vector. I find it to be quite a little bit easier to use, and they use what they call HNSW, is hierarchical navigable small world kind of like techniques or algorithms to do it too, and also it supplements some of the I mentioned earlier about approximate nearest neighbor type of like algorithms to it. So that's that. And also, to one thing, point out, Chroma seems to be also popular, and fast came from Meta too. So you can, if you look into it, it appears to be quite popular. And the other, like Quadrant and Weaviate, this seems to be kind of popular vector database that's open source. Okay, so really quickly too, basically kind of summarize again what are vector embeddings being used for. So as you can see, we're kind of looking at data multidimensional. Then it can be used for searches, for clustering, for like product recommendations, anomaly detection, diversity measurement, and classification. You can kind of think of it beyond just this, strictly like ChatGPT type of uses too. Okay, so just really quickly, the problem with some traditional database in AI, you can still use it, nobody is stopping us, but then as you have to be aware that traditional databases does not handle multidimensional data as well as vector-built kind of database to handle the multidimensional data. Now, in some cases, I've seen folks doing ChatGPT app in which you can have different, data flowing through different points. At some point, you can still maybe keep your existing, let's say, SQL Server doing something, and then later you're going to do some searches. You can kind of plug in a vector database to help you to store the data and doing queries too. So that's just some example of that. But traditional database in general, you don't want to use it to do multidimensional data search. Okay, so this one is just a really kind of quick one too, to show you just an example of a RAG application that kind of like to do how the database fit in and how the data flows, the chain, all of these things. But again, this is just a quick example of that. Okay, so I think I may have a minute or so. I'll just really quickly show you. Okay, over here. Oh yeah, this one is just a hello world. I just quickly show you, but this one doesn't do as much. It just does like a model associated with the API key and then does a generate. And so it's not like too much to it, but we can also quickly kind of run it and show you too. I think it's so all it does is just comes back with hello world, nothing like too special. But I also wanted to kind of quickly to show you, there's actually, I have multiple things, and this, sorry, yeah. real quickly. There's actually also an easy rag I was doing. Wait, over here. So real quickly in here. So again, right there, not this one. This is an example actually from this, also from what you call LangChain 4J2. Easy rag over here too. It's just a rag, but it doesn't do all of the data of the magic of cleaning the data, doing all of these, sorting all of these things. But just want to really quickly to show you is that you can actually do a load documents and load it from an external source like a text file, for example. And then you can do an AI services and doing all of these things, and essentially too then associate with your chat memory and then content retriever, and basically then do a build, and you should be able to then do the retrieval quite quickly as well. This is just an example of an easy rag thing. So you can kind of, let's say, quickly kind of run it to show you. Yeah, this one I ran it. But again, this doesn't have any what you call it, like a UI to it. So over here, I can just say this, and I can just say, maybe, let's see, what is JCon? Let's see what if it knows. Okay, okay, it retrieve. I think it may not know too. Oh, wait, you know what? Because I plug in this one. I load the data from a rising wave thing. So I think it's kind of plugging, because it can't find it. So then it comes back with something that may not be correct, So anyway, that's just kind of a quick example to show you. But I realize I'm kind of timed too, so won't get into all the details now. But I can also share with you some other things, which is quickly, right, about this ChatGPT. The benefits is basically, think of it like you can ask it, and then you shall receive. You always will receive something, but make sure you ask wisely at this point. Challenges, I think we should be more aware of that, is that hallucinations. It's basically if your LLMs is not equipped to answer, doesn't have the answers for you, just be aware. Like I mentioned to you, some of the earlier forms of GPT-2 actually started swearing and then giving you wrong things, so you have to be careful to what it gives you back. And I was talking with Hedy too last night, the ChatGPT can be very dangerous. You can be thinking you asked the right thing, but it's actually doing the wrong thing, producing to you wrong code. And so be very careful about that. And then another thing to be aware of is the ethical concerns too, right? And it can be, nobody's overlooking it, and what you're doing, and basically you can be unaware of what it gives you back. So you have to be careful. And I think right now all of the governments are trying to set up regulations to control it, but I don't think anything has truly happened yet. So okay, and then another thing, of course, then I point out too, that's why we're using rag pattern, because the LLMs itself are just very limited, right? Even though it's big, but it doesn't contain all the information that you need. So if you are working for an insurance company, you can kind of consider using some of your private data can be supplied to your LLMs to supplement it using rag pattern, or if you're a law firm, whatever, right? You can do that too. So these are just some of the things you need to be aware of. Okay, so I think I'm time, but just want to quickly share with you. If you're interested in this slide deck, this is the QR code and also the bit.ly link. I'll also be sharing with you my contact information too, so if you miss, don't worry about it. I'll share with you after. Yeah. Okay. Yes, it is. Yes, I have, but just let me real quickly go to the next page. And this one too, just thought I'd share with you. I found too, there's this OSS Insight collection. Is somebody doing a very nice measurement of open source software in different categories. So I found this vector search engine too, and it's showing you, for example, I was sharing with you Milfis and PG Vector. Those are the more popular ones. So that's what I was sharing with you. But there are also other OSS software. You can find out the rankings. It's based on the number of GitHub stars. So it's not truly kind of very fair, but just to share with you if you're interested. Okay, and then I also have I mentioned about my stream. I also try to go back to doing Twitch stream after my set of travel. So my Twitch channel is here, and also I multi-stream to YouTube as well. So if you want to follow me there, you can follow me there as well. And I try to do more examples in there. So coming to conferences, usually it's very short, so don't have enough time to do many things. So. Okay, and then with that, I want to just thank you again. And this is how you can stay in touch with me. My LinkedIn profile, my Twitter or X handle, and also I have a Discord server too if you like to stay in touch and kind of have more conversations too. So I welcome your comment, and please, yeah, if you're working with ChatGPT or want to share with me your projects and want to come on my Twitch stream, you're welcome to join me as well. So with that, I want to thank you again, and really appreciate you. So thank you. Yeah. Yeah. Okay, and I think someone has a question, right? Yeah.
Thank you so much for the vector introduction.
Thank you.
I'm somebody who's working a lot with open source Apache Solar.
Yeah.
I'm just wondering how would a vector search compare with the traditional index-based search,
Oh.
Apache Solar or Elasticsearch?
Oh, okay. Yeah. So the question is about how does traditional search like Solar, Lucene, right, the kind of searches compare with vector search? I think the difference is that now with vector search, we're working with vector data type. So that's kind of one of the fundamental differences, because we're talking about data that's, as you can see, there are arrays of floating point numbers that we are performing searches on. So it's a kind of different data type that we're talking about. But I think the Solar and Lucene kind of searches, all the old ones, they are not handling. I don't believe so. Or maybe they have. I just haven't worked with.
Sorry, I understand what you're saying.
Yeah.
My question is more about I have the traditional search requirement.
Ah.
I want to find, the whole thing talks about finding data, right?
Yeah.
Yes, you can use machine learning and generative AI to simplify the queries for
Yeah.
humans. But once the query is sort of developed, I ask a computer, I want to search for something, and I have millions and millions of documents sitting there where the answer lies. Should I be embedding all the documents into vector search, or should I just translate that query into something that my traditional search engine understands?
Oh. Well.
I know it's a
ju-
tricky one, so I thought
Yeah.
you probably heard it from where before.
Yeah. Okay. So that I don't have the answers for you right away. Maybe.
The answers I'm looking for, because there's a use case I'm currently chasing. There's the first one about the vector databases.
Oh,
I
okay.
was hoping you had the answer.
Yeah, this one I have to think of. Even I have to think about it. Maybe Soham, you have answers for me.
I think it depends on the data.
Yeah.
Of these use cases and business requirements.
Which is true. Yeah.
Let's say the vector search much fits for example, unstructured data like images. If you want to look inside for different images, you have to use vector database for the searching, because it's not able to split the picture for the different. It's only possible if you keep the picture as a vector, and then you can search like the beautiful view on the sea. Then you will get the pictures with the sea and beautiful view on the sea.
Oh, yeah. It's true. I think it is very true. It will depend on your use case and depend on the type of data you have. And yeah, so yeah, I would think that's what it is. I just haven't gotten to actually develop some of these other kind of edge cases kind of scenario that I have to think about how it would be done otherwise too. So yeah. So yeah.
Even for text, I think the most important thing that you can do with vectorized searches is that you can take the semantics of a sentence or a topic you want to search, put it into a mathematical notation, and then search on the mathematical notation. Otherwise, you would have to search for words in a sentence that may not be familiar or similar in a
Yeah.
context.
Yeah.
You did it on the vector space. If you search for dog, you will get dog, cat, and anything like that. But if your semantic question is, what would be a good pet for me if I live on a boat? Dog would not be a good idea, because the dog would never get food. Maybe fish that you can carry with you to your boat would be a better idea.
That's right. Yeah, and I think because it also you have to store all your data too, so it depends on how you store it, and so yeah, which means you need to have a much larger set of data being stored first, and then from there, when you need to search, the query one will also need to be converted using the same model, embedding model, and then you be able to then search it. Using all of the approximate nearest neighbor kind of techniques, right? All of these to do all the searches. Yeah. So it will rely on all of the math, and also the different contexts will come back differently too, different models, for example. So yeah, so I don't think we can think of it like the traditional kind of search, like, okay, search for this and comes back with very direct, but because of the multi-dimensional nature of your search, it's going to be more complex, and it involves all of the linear algebra, like cosine similarity searches, all of these things that are being involved in there. So yeah, it will actually will depends. I think the more I think about it, yeah. Anybody has suggestions about that? Yeah.
I'm just wondering about the ChatGPT is use only one huge language model, or it has a lot of. I'm just wondering. I don't know. Maybe you know the answer for this question.
ChatGPT.
Under the hood, what they are using. I mean, they have only one huge language model, or they have separate language model
Oh.
together.
Yeah, I think that there's still, yeah, you're working with some language models. Yes, it's one huge one. But I would think, well, from what I know, I think there are some cases in which you can actually have multiple models that are being kind of put together and do searches upon. I have heard of that, but I haven't seen. Like, so far, all of the examples, usually you kind of establish connection to one model, and then you do whatever you need to do. But I think there should be use cases in which you do need to have connections to multiple data sources or multiple models to kind of do your search, from too. I think there are those cases as well, but I just haven't had a chance to use it yet to see how it actually would work. Yeah. But I think that's theoretically you should be able to. I mean, you shouldn't be limited to only searching for one model. You can have many models you should be able to kind of source from. I believe so. But the techniques of how to do it, I think that will be maybe my next talk. Yeah, I gotta do research. Oh, that actually is a good idea. Gives me an idea to do my next search or next talk, on something like this. But those are great questions. Thank you. Yeah, thank you. Yeah, I hope it's interesting enough for you all to find it to be kind of inspiring you to go look for answers too. I think this is still a very new topic. It's so fascinating, and a lot of researches are still being done, and I don't think there's any fixed answer to anything yet. And these days too, there are also many AI-related meetups everywhere. I myself too am involved with an AI camp in Chicago too, and we are constantly having speakers coming in, and there are new things that pop up, and just it's hard to get caught up with all of these things. But whatever questions we are asking, I think is very good to be able to kind of help us to reach the next level, I think. Yeah, we need to keep asking the questions about all of these things. So, yeah, thank you. Yeah, really appreciate all of your questions. Thank you so much. Yeah, thank you. Yeah, okay. Yeah.